Okay, so let's talk a little bit about the conclusions from this lab. Now, I did all 3 runs. So you can see run 1, run 2, and run 3. This is what my data ended up looking like right here from run 1, run 2, and run 3. Now you can see here my horizontal velocity varied quite a bit, around 1.5, 3, and a little bit under 1. My horizontal acceleration, these two here, these are basically 0. That's really important that these are basically 0. On run 3, I checked my data, and I'm not really sure why this isn't closer to 0, but it's still really, really small, at least compared to the acceleration due to gravity. Now, if we look over at the vertical acceleration, these are, we got almost negative 11, negative 10.5, negative 10. This is the acceleration due to gravity. Now, the results aren't perfect, but based on the equipment that we have, an error of 10% is doing pretty well, and we're well within that margin of a 10% error. 20% error, maybe getting a little sloppy, but still not too bad. If you were getting values for acceleration that were 12 or 14 or like 6, you might want to go back and check your data, adjust those points, make sure that the point where you selected the ball or the marble, make sure that you selected the middle of the blur, not the beginning or the end. Now, it's pretty interesting here. If we look at the time in the air, all of my time in the air, and I had to estimate a little bit, but within 1/100th of a second, was all identical. And this is the key piece here. It didn't matter how fast the ball was rolling off the table, the amount of time spent in the air was exactly the same. I'll repeat that. Didn't matter how fast the ball was going on the table, it spent exactly the same amount of time in the air. Now that's weird. That is a little weird. What's happening is the ball is definitely going different distances, right? The faster it went, the farther it went from the table. You can see that in my videos, and hopefully you could see that in your videos. But this fact that it's taking the same amount of time in the air is a crucial observation. And in fact, if I'd taken the marble and just dropped it from the edge of the table, it would have taken the exact same amount of time. And what that tells us, or what it implies, is that the horizontal motion, how fast it's going horizontally along the table, does not impact how long it takes to fall from the table down to the ground. Think about that one. Let that one soak in a little bit. Maybe even pause the video, because you can do that. This is a really important conclusion. And so what this means is that horizontal motion and vertical motion do not impact each other. It does not matter how fast that marble goes off the table, gravity is going to pull on it just the same, with the same acceleration pulling it down to the ground. And that's going to be super useful as we move forward. And so what that means, if we start talking about what's called projectile motion, where we're starting to throw things, or we're going to start pretty simple with just rolling things off tables or rolling things off cliffs, we now have objects that are moving horizontally and vertically. And for each of those motions, horizontal and vertical, we're going to have a set of variables, the same variables that we had for one-dimensional kinematic equations. And the horizontal velocity does not impact the vertical velocity, the vertical acceleration. They are fully separate except for one variable. Think about that one. Take a pause a little bit. Which of those 5 variables is going to be impacted, or more specifically, which of those 5 variables is going to be the same from the vertical motion to the horizontal motion? Which variable is going to share the same value? The answer to that is that it's the time. It takes the same amount of time for the object to travel horizontally as it does vertically, because it's the same motion. So that means we're going to have a column of variables for the horizontal motion. We're going to have a column of variables for the vertical motion, and the delta t's in each column is going to be identical because it is the same motion. It took the same amount of time. But their velocities, their accelerations, and their displacements are going to be different. So that is the key conclusion. Horizontal and vertical motion are separate. The only thing that connects them is the time taken. And there you go. That's it. When you guys come back to class, we're going to be talking about projectile motion. We're going to be talking about objects moving in 2 dimensions, moving vertically and horizontally. It's not nearly as scary as it sounds. It's only moderately scary. See you guys when you come back.